Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to start a two-part series on the topic of exponents and surds for grade 11 mathematics. In this video, which is part 1, we're going to focus on the simplification of both exponents and surds. And in part 2, which is the next video, we're going to focus on solving exponential and surd equations. On that note, if you're new to this channel, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 of this video and new videos we upload in the future. Now straight to the topic. When we're dealing with exponents, we're referring to numbers that can be written as a power. For example, 2 to the power of 3 or 2 cubed, where 2 is the base and 3 is the index or exponent, and that is equals to the number 8. Now these exponents have got two relatives that we'll look at in grade school. The first one being the surd, and that is also one that we're going to look at in detail in this video. The second one is the logarithm, and this one will focus on in grade 12 in detail. Now this is how the surd and logarithm are related to exponent. If 2 cubed is equals to 8, that means that therefore the cube root of 8 is equals to the base 2. Also, if 2 cubed is equals to 8, that means then the logarithm of the number 8 to the base 2 is equals to the index or exponent 3. Now, all these have got their laws that govern operations and calculations, and these laws are related also and similar because of the relationship all these three have. Now, let's look at an overview of the laws that we've covered so far. Laws of surds. Let's start with the laws of exponents. There's nothing new here. We've done this in previous grades, so this is just an overview. Remember, if you multiply powers of the same base, you must add the exponents. If you divide powers of the same base, you must subtract the exponents. If you raise a power to another power, then it means that you multiply the exponents. These laws haven't changed. They're still exactly the same. Also, with surds, if you have a power with an exponent that is a rational exponent, in other words, an integer over another integer, that means therefore that if you've got a to the power of m over n, for example, that simply means you can express that exponent, the rational exponent, in surd form as such, the nth root of a to the power of m. Similarly, if you've got a to the power of 1 over m, that can be expressed as the nth root of a, which is still a to the power of 1. That's just an overview. Now let's look at some examples of how we apply these laws and how we solve problems on surds and exponents. Now, depending on how the question comes across, there are different ways and rules that you need to apply in order to simplify. For example, if you've got number 1, where it says simplify an expression like this, you're definitely going to use what we call the laws of exponents that we've just looked at now. Now let's see how that happens. Now, in a question like this, the numerator is basically not troublesome at this moment, so you can leave it like this. For now, of course, you're going to deal with it in the future as well. So you go 3 times a to the power of negative 2, b to the power of 15, c to the power of negative 5, all over. Now you deal with the bottom one. Now the bottom one, if you notice, you've got a power, right, raised to another power. So you use this law that says that if you raise a power to another power, you must multiply the exponents. And that is exactly what we do here. So we multiply the exponents of each and every one of these powers inside the bracket by the exponent outside the bracket. So a to the power of negative 4 times negative 5 over 2, that becomes positive 20 over 2, which is equals to 10. So that leaves you with a to the power of 10. Yeah. Now b, we're multiplying 3 by negative 5 over 2, and that leaves us with negative 15 over 2. Negative 15, so that is to the power of negative 15 over 2. Now for C, you're multiplying 1 by negative 5 over 2. That leaves us with simply negative 5 over 2. So that is equals to 3. Now also, there is a law that says if you divide powers of the same base, you must subtract the exponent of the power at the bottom. So for the a's, in this case, the a's here, we go minus 2 plus, sorry, minus 10, minus 2 minus 10, and that leaves us with negative 12. So you go a to the power of negative 12. And then b, we've got 15 minus negative 15 over 2, which is basically plus 15 over 2. Then you use the rules of adding common fractions, so that becomes with an LCD of 230 plus 15, which when added together give us 45. So that is 45 over 2 to the power of 45 over 2. And then the c, we've got negative 5 minus negative 5 over 2, which is plus 5 over 2. Using the laws of adding common fractions, we've got an LCD of 2, sorry, we've got an LCD of 2, not C, LCD of 2. And then we've got minus 10 plus 5, which is negative 5. So that leaves us with negative 5 over 2. Let's fix that. Negative 5 over 2. Negative 5 over 2. Now, according to the rules of exponents and powers, when you finalize, you must leave your exponents as positive. Whenever you've got a negative exponent, for example, like a to the negative 12, we must take it to the bottom so it becomes a positive. The only one we leave at the top is b to the power of 45 over 2. B to the power of 45 over 2. So that becomes b to the power of 45 over 2 at the top. All over the rest we take to the bottom. So that becomes a to the positive 12 at the bottom, a to the positive 12 at the bottom, and c to the positive 5 over 2 at the bottom. And that's how you solve that question that comes like this. Now for the second scenario, if you given the question simplify, and the question comes like this. Step number 1, you break up all the exponents into individual powers. So that becomes 3 to the power of m times 3 to minus 3 to the power of m times 3 to the power of 1. That's what this means there. 4 times 3 to the power of m minus 3 to the power of m. Now notice something. You've got a common factor here that you're ending up with. That is 3 to the power of m and another 3 to the power of m, a 3 to the power of m, and another 3 to the power of m. So what you do is you take out that common factor like you would when you factorize anything with a common factor. So that is 3 to the power of m in bracket. Now what you are left with inside is 1 minus 3 to the power of 1, which is the same as 3. You can write this as 3 to the power of 1 if you wish, but it doesn't really change the fact that it is still 3. So we also take out the common factor at the bottom, and we're left with 4 minus 1. It's 4 minus 1. Now the 3 to the power of m's cancel out, and you're left with 1 minus 3 is equals to negative 2 over 4 minus 1 is simply equals to 3. So you're left with minus 3 over 2. And that's your answer there. Next scenario, is when you're given a situation where they say write as a radical and simplify. So step number 1, change this decimal fraction into a common fraction. So that is equals to, everything you leave the same, to the power of 1/3. So you go 8/1 and 1, 2, 3. You've got 3 digits after a comma, so you leave it with 1 and 3 zeros, so that becomes 8/1000. Now remember, they said you must write as a radical, so meaning that you write as a cube root like this. So that is cube root of 8/1000. Remember, 8 is a cube of 2 and 1000 is a cube of 10. So that is equals to, you break this up, that is the rule. So you can break this up. Remember, I told you surds have got similar laws to exponents as a result of their relationship. So a case like this, where, for example, in exponents, you have a situation like this, that when you have a number over another number, all raised to the power of n, you can break up this and into separate powers, so that becomes a to the power of n over b to the power of n. That's exactly the similar rule we've used here for our surds over here. So we had a situation like this, we broke it up like that. Now that is equals to, the cube root of 8 is simply equals to 2 over the cube root of 1000, that is 10. Now simplify this. 2 goes into 2 once and into 10 5 times, and your answer becomes 1/5. Next scenario, you are given a situation where you say simplify b minus a over a to the power of half minus b to the power of half. Now this one may look impossible to solve until you realize that a to the power of a half is basically, if you square that, that gives you a to the power of 1/2 multiplied by 2/1. Using that law that says if you raise a power to another power, you multiply the exponents. Now these two cancel out. 2 cancels out with 2. You're left with a to the power of 1 here. So meaning that basically b is just the square of b to the power of half, and a is the square of a to the power of half. So this is what you do. You go, that is equal to, this is equals to, all right, you express the numerator as a difference of 2 squares. So that is b to the power of half all squared minus a to the power of half a squared. Notice that this is a difference of 2 squares, 1 square minus another square, all over a to the power of a half minus b to the power of a half. Now let's factorize the difference of 2 squares here at the top. So that becomes 2 brackets. In the first one, you put the square root of the first square. The square root of the first square in this case is b to the power of half, because the square is b, same here. Now in the second bracket, you put the square root of the second square, which is a, so that a to the power of minus half. Now in the middle, you put 1 plus and 1 minus. That's how you factorize the difference of 2 squares. Now that leaves us with a to the power of half minus b to the power of half, which is very similar to this. B squared minus a squared. It's just that now everything is reversed. So what you do to correct that, so you make them similar, is you put a minus in front of that. So you then go that b to the power of half minus a to the power of half. Now you can switch them around. So now notice that now this at the bottom cancels with that at the top, this at the top, and you're left with minus, because you divided by minus, so that you're left with minus. So you're left with minus in brackets b to the power of a half plus a to the power of a half. And that's how you solve that complicated example there. Now next scenario is when you are given a situation where you're required to simplify to the simplest sort form. For example, write the following in simplest sort form and you've got the square root of 50. What you do in a case like this is you break up what's inside the square root sign into a product of two factors, one of which is a perfect square. Now you can break up 50 into 25 times 2. 25 being a perfect square. Now that makes it easy for us to now then express it like this. So we've got a square root, a perfect square. So we take the square root of 25 is 5. So we take that out. Take that out and we're left with, so let me fix this 5. We'll take that out. So that's 5. And we're left with, okay, another 5. We leave that, so we are left with 5 square root of 2. And that's our answer there. Another situation is when we expected to simplify a situation like this. This is very easy. So you just basically put everything in one square root. So you go a squared times b cubed times b to the power of 5. That is, when you multiply powers of the same base, you add the exponent. So that will be b to the power of 3 plus 5, which is 8. So that is b to the power of 8. Let me fix that. So that is b to the power of 8. So that will be equal to everything in the same square root. So that is a to the power of 2, b to the power of 8, and c to the power of 4, which is equals to, now find the square root of each. The square root of a squared, that's a. The square root of b to the power of 8, that b to the power of 8 times half. So that gives you 4. That's b to the power of 4. The square root of c to the power of 4 is 6 to the power of half times half. So that's c to the power of 2, c squared. And that's how you solve that. Next question. You are given simplify square root of 20 minus square root of 5 all squared. Now in a case like this, you go keep the squares. Now do the same thing you did with the square root of 50 with the square root of 20. Break it up into factors where 1 is a perfect square. Now the factors of 5 where 1 is a perfect square is 4 and 5. 20. So that's 4 times 5, where 4 is a perfect square, minus square root of 5. Now notice that this gives us, okay, that is equals to, in bracket, if you take out the 4, so that becomes 2 square root of 5 minus square root of 5 all squared. Notice that this square root of 5 are similar, so that becomes equals to, all right, all squared. That is the same thing as 2 goats minus a goat. 2 goats minus a goat, that is 1 goat. So we're left with the square root of 5. And the square root of 5 squared is simply 5. And that's how you solve that. Next scenario is when you've got a situation like this where we've got a square root of one number over another. Same story, break it up into a product of a perfect square with another number. So 12 can be written as 4 times 3. 4 is a perfect square all over square root of 3. Now notice this. Take out the square root of 4, so that's 2 square root of 3 over square root of 3. Now the square root of 3's in this case cancel out and you're left with just 2. And that's your answer there. Next situation scenario. Write in simplest set form. Here you've got a square. Here you've got a square. And a square root and a cube root. They're not the same, they're not similar, so you must make sure you never mix them together. You cannot multiply them together unless you can first simplify them out, and then if they're numbers, then you can multiply them together. Now break this 75 up like you did with the 50 into a product of a perfect square with another number. Now the perfect square I can think of here is 25, so divide 75 by 25 and that will give you 25 times 3. So that becomes 25 times 3. 25 times 3. Multiply by, or this cube root of, okay, first notice that your 48 here, your 48 is raised to the power of -1, meaning that you can express that as 1 over, about that, 1 over 48. So this cube root of, so that is equals to the square root of 25 times 3 multiplied by cube root of 1 is 1 over the cube root of 48. We're breaking them up. All right. So that is equals to 5. Take out the square root, 5 root 3 over. All right. You break up the cube root of. Now you find a perfect cube that you can break up into factors with another number that gives you 48. Let's try 8. 48 over 8. Perfect. So that gives us 8 times 6. 8 times 6. All right, now the cube root of 8 is 2. So that gives us 5 root 3 over 2 cube root of root 6. So let me fix that. 2 cube root of root 6. 2 cube root of root 6. And that is how you solve that. Now another similar scenario is when you given the question simplify and you've got 2 surds that you're supposed to simplify, add it together. Same story as with the root 50. Break 147 into a number multiplied by a perfect square. Let's try and see. 147 divided by 49. Yeah, gives us 49 times 3. 49 times 3 plus 108. Try, what is the, okay, try 36. 36. 108 divided by 36. That gives us 3. So that's 36 times 3, which is equals to, all I did was pick a square, a perfect square, and divide the numbers by. Okay, so that is 7, taking out 7 out, so 3 plus that is 6 root 3. Now notice that these root 3's are similar, so that's 7 goats. That's the same as saying 7 goats plus 6 goats. That gives us 13 goats. So that is equals to 13 root 3, and that is your answer. Next scenario, you've got a situation where you expected to rationalize the denominator. This is what you do. If you have a situation like this, you go there is equals to, leave the numerator exactly the same and the denominator for now. But what you do is then you multiply this with a denominator in this fraction. That gives you a scenario of a perfect square, meaning that you've got t root 3 t minus 2, because when you multiply these together, they give you a difference of 2 squares situation. So what you do to the bottom, though, you must do to the top. So that is equal to the top. You can leave exactly the way it is. Just apply brackets to make sure that it's clear what is what and who is who in the zoo. Divided by, now the bottom is what we call a difference of 2 squares. So that becomes the square of the first term, so which is t in this case. So that will become t minus the square, sorry, there was, yes, minus the square of the second term. So that is 4. And that's how you solve that. Now the last one is also a difference of 2 squares situation where you are rationalizing the denominator. Notice that that is raised to the power of -1, meaning that that simply means you can make that positive by expressing it like this. You can say all to the power of 1, but it doesn't really make a difference. It doesn't change anything. So that's how you express it. So you go equals to 1 over 1 plus root m, and you multiply that with a difference of 2 squares equivalent situation. So that's minus root m, 1 minus root m, because the bottom here will give you a difference of 2 squares scenario. That's why you do that. So that is equals to denominator, you can leave as that. It's 1 times, so that's 1 minus square root of m over, and the bottom, the denominator becomes a difference of 2 squares, so that is 1 minus m. And that is how you solve that. We've come to the end of the video. Please don't forget there is part 2 coming in the next one, where we look at how to solve exponential and surd equations. Thank you very much for your time, and bye.